Hello, welcome to another section of our IoT tutorial. In this section, we are going to prepare the development environment that will be used to develop Azure IoT projects on the ESP32 device. During the tutorial, we will use the Eclipse as an IDE tool, the ESP-IDF, which is the official development framework for the ESP32 and ESP32S series. Also, we will use azure-iot-sdk-c, which is C99 SDK for connecting the IoT devices to Microsoft Azure IoT services. Please note that I am not one of the Arduino fans, so I will not talk about the Arduino at all. Also, please download the guidance file from the video description, which contains a few links and some information that will be used during the tutorial. The first step will be installing Java Development Kit. So if it's already installed, you can jump to the next step. But please make sure that Java is included in Windows bus. You need to select the suitable package for your operating system. Currently, I am using Windows 10 64 bits, so all the incoming packages will be selected accordingly. We need to copy the Java bus to be used later. Once the Java Development Kit is installed, we need to add it to Windows bus. We can verify that Java bus is identified by Windows by opening the command prompt and type java-version command line, which will display the installed Java version. If you don't see the Java version information, go back to the previous step once again to see if you made a mistake somewhere along the way. The next step is installing Python. So if it's already installed, you can jump to the next step. But please make sure that the Python is included in Windows bus. The important thing in this step is to add Python bus into Windows bus. We can verify the Python bus is identified by Windows by opening the command prompt and type Python command line, which will display the installed Python version. If you do not see the Python version information, go back to the previous steps once again to see if you made a mistake somewhere along the way. The next step is installing Git. So if it's already installed, you can jump to the next step. The next step is cloning the ESP-IDF repository using Git. The ESP-IDF is the official development framework for the ESP32 and the ESP32S series. Now, go and select the folder location which will be used to download the repository and make a complete local copy of the ESP-IDF framework. Then, use the link from the guidance file to have a recursive cloning for the framework. When the cloning finish, you can check the downloaded framework. The next step is cloning the azure-iot-sdk-c repository using Git. The azure-iot-sdk-c is the C99 SDK for connecting the IoT device to Microsoft Azure IoT services. Now, go and select the folder location which will be used to download the repository and make a complete local copy of Azure IoT SDK-C. Then, use the link from the guidance file to have a recursive cloning for the SDK. When the cloning finish, you can check the downloaded SDK. The next step is downloading and installing of Eclipse IDE for C and C++. After installing Eclipse, run the IDE and select your workspace location and make sure that the workspace path does not contain any space characters or it will introduce many problems. The next step is installing IDF Plugin. This plugin provides an easy way to integrate the ESP32 development environment with Eclipse. Also, it provides better tooling capability for the developing, editing, compiling, flashing, and debugging the ESP32 device with the addition of installing the SDK configuration and CMake editors. Now, go to Help, install new software, get the link of the plugin from the guidance file, then add. You can type any name of the repository link. Select all the available tools. No problem, you can bypass the warning and select install anyway. After installation, you will need to restore the Eclipse. If you check the help menu once again, you will find two new items are displayed. We will select the ESP-IDF tool manager, then install tools. This will install the required tool to build the firmware for the ESP32. These tools include Python, Git, cross-compilers, menu config tool, CMake, and Ninja build tools. You will be prompted to enter the ESP-IDF location and the Git location as well. Press install. The next step is to load our first example, which will be used to test our ability to build our first simple example. And for simplicity, we will use the blink example. In this example, we will just blink the LED on and off periodically. The next step is configuring the launch target, such that we need to tell the CDT to use the toolchain for our project, so all the headers will be indexed and resolved. Select the ESP target, After that, we will give it a name, ESP32. Then we need to select the serial port, which will be used by our ESP32 device. Then we need to adjust the launch configuration. First, we need to define the location of the application which will be used to compile. Currently, this application is Python. Then we will select the working directory and we will select the project name, which is test. Then we will add the flashing command. We need to add the path of the ESP-IDF tools. Please note that we are using the slash, not the backslash, in the path. Also, please adjust the COM port to the same COM port of the ESP32 device. The next step is to build the Blink project. The project built without any problems. The next step is to configure the SDK. In the past, this was done by command line, but now it can be easily done directly from the Eclipse using the installed tool by clicking on sdconfig file. For now, we are interested in the example configuration, which is configuring the hard-coded parameter in our project. So they are giving us a GUI to configure the hard-coded parameters. In the current Blink project, we will configure the GPIO number, which is used to connect the LED. We will select the GPIO2, which is used by our ESP32 module. The next step is to configure the serial output, which will be used to receive the logged data from the ESP32 module. The last step is to flash the Blink project to the ESP32 module. At this step, we need to press the boot button on the ESP32 for a couple of seconds to enter the bootloader so we can flash our project. Now our Blink project is flashing. After flashing the project, we can see in the terminal window the received logs from the ESP32 module, which is indicating the on and off for the LED. And we can see on the right hand side of the screen a live video of the ESP32 with blinking blue LED. Finally, I hope this tutorial was helpful. See you in the next one.